Hello! So today what we're going to start talking about is summation notation and how to solve summations. And um, knowing how to do summations and applying these different formulas is going to help when we start talking about one of the fundamental problems of calculus, which is finding the area under a curve. So let's get started. So if we want to write the sum of n terms, let's just arbitrarily label them as a1, a2, a3 out to an, we can rewrite that as the sum from 1 to n of ai. So this big E right here is a Greek sigma, and we use this to equal sum. So whenever you see a big sigma like this, a capital sigma, it means sum. And so then we have I equaling 1 down here. So I is what we call your index, which we'll talk about when we do an example. And then the numbers that are on the bottom and top tell you where to start and where to end. So 1 in this case is going to be your lower bound of the sum. It's going to tell you where to start. And then the n on top is what we call an upper bound, and it's going to tell you where to end. So those are just the different parts of a summation. So now let's see how that actually works. So let's do a concrete example first. So why don't we find the sum from I going from 1 to 5 of I plus 2? Okay, so that means wherever we see an I, we're going to start by plugging in 1, and then we're going to plug in 2, 3, 4, and out to 5, and then just add all of the terms together. So to find our first term, we're going to plug in 1. So we're going to do 1 plus 2. So this is A1. Plus, now we're going to plug in 2 for I. I'm going to go 2 plus 2. That's going to be A2. Plus same thing, but now we're going to go 3. You just go up by integers. Summations always happen over whole numbers. So now we're going to do 3 plus 2, which is A3. To find A4, we're just going to plug in 4 for I, so 4 plus 2. And then our last term is A5, so we're going to do 5 plus 2. And now we know to stop because that's the number, because the 5 matches the sum up here. So once you reach plugging in that number, you know to stop. So now what we're going to do is simplify. So we're going to get 3 plus 4 plus 5 plus 6 plus 7. And now all we have to do is add them together. So 3 plus 4 is 7, 7 and 5 is 12, 12 and 6 is 18, and 18 and 7 is 25. So the sum from I going from 1 to 5 of I plus 2 is just equal to 25. So that's one way to go about doing it. So when your indexes are small, when you go from 1 to 5 or 1 to 6, it's really easy to just plug in and do the math. But what if you were doing something that was like I going from 1 to 100 of I plus 2? That's a lot more. You'd have to find 100 terms and then add them together, which you could do it, but it would take a lot of time and there's a lot of room for error there. So what we're going to learn about now is different formulas that we can use so we don't have to find every single term. So before we learn the rules for summations, we have to know their properties. So these are just like the properties for derivatives and integrals that we just talked about. So if the first one is your constant rule. So if you have a constant inside of a sum, just like when you have an integral or a derivative with a constant on the inside, you can just pull it out. So you can pull your k to the outside of the integral, just like of the summation rather, just like we did here. And then same thing, the bottom one is just sum and difference, just like we have for derivatives and integrals. So if you're taking the sum of a plus or minus b, you can just break that up into two sums, so you can sum up a and then add or subtract it to the sum of b. That's all it is. So now that we've gone over those simple properties, we have our summation formulas. So these are 4 things that you really want to have memorized, because having them memorized is going to help you on quizzes and tests and your homework, especially if your professors don't give you the formulas for tests and quizzes. You really need to know them in order to do the problems. So when we're summing up, so for this first one, when we're taking the sum of a constant, so if like an example would be the sum of, from I going from 1 to 5 of 2, all you do is you take your constant 2 and multiply by the number on top, which is n. So we just do 2 times 5 is equal to 10. So that's how you would do that. So in rule number 2, if you have an I on the inside of your sum, all you do for that is you take this n, you plug it into n, multiplied by n plus 1, and divide by 2. So an example would be the sum, let's just keep with our 1 to 5, of I. That's simply just going to be 5 times 5 plus 1 over 2, which is just equal to 5 times 6 over 2. We can cancel between the 6 and the 2. We get a 3 left up top, so this is just 15. Okay. So that's all it is. So now we have rule number 3, which deals with I squared. So whenever you have I squared, again, you just take whatever number is up top and plug that in here for all of these n's. So we're just going to plug into this formula of n times n plus 1 times 2n plus 1 and divide it by 6. And that's going to be our sum. So for example, again, with I going from 1 to 5, that's just equal to 5. 5 plus 1 is 6. Times 2 times 5 is 10, plus 1 is going to give us 11, all over 6. We can cross cancel with the 6's, and we're going to get 55. And then our last one that you really need to know at this level is the sum of I cubed. There are formulas for I to the 4th, I to the 5th, in higher powers of I, but you really don't need them at the level of calculus that you guys are in. So again, we're just going to take n and plug into this formula. Let's see how that works. So example here, I cubed going from 1 to 5 is just going to be 5 squared times 5 plus 1 all squared over 4. Well, that's just equal to 25. And then this is 6. 6 squared is just going to give us 36 over 4. We can cancel the 4 with the 36 and make that a 9. And now all you have to do is 25 times 9, which if we do the math real quick, should be 225. It's going to be 45. Yep, so we get 225 for this sum. So that's just how you go about using your formulas. So now we're going to do a few examples to see how to use them when our sums have multiple parts. So our first example is going to be the sum from 1 to 5 of 3i squared plus I. So the first thing we want to do is break this up into two sums first. So let's do the sum from 1 to 5 of 3i squared plus the sum from I going from 1 to 5 of I. And then we're going to use that constant rule to bring the 3 outside of the first sum. So we're going to get 3 times the sum of I going from 1 to 5 of I squared plus the sum of I going from 1 to 5 of I. And so you always want to break your sums up like this, and you want to keep breaking them down until you just have i's left on the inside, so that way you know how to use your formulas properly. So now we're just going to plug in for our formulas. So I'm going to do 3 times, and now the formula for I squared just to write them off to the side, that's n times n plus 1 times 2n plus 1 all over 6. And the sum for I was just n times n plus 1 all over 2. So I suggest that as you're starting to do these problems for your homework, every time you do a problem, write out your basic formula, because rewriting it all the time and saying it out loud to yourself is going to be a great way to help you memorize them. So n in this case is 5, so we're going to do 5 times 5 plus 1 times 2 times 5 plus 1 all over 6 plus the formula for I is just going to be 5 times 5 plus 1 all over 2. So now we're just going to simplify with our numbers. So we're going to get 3 on the outside still here, 5 times 6, and then 2 times 5 is 10, plus 1 is going to give us 11, all over 6, end our parentheses, and plus 5 times 6 over 2. So now we're just going to simplify and then multiply our 3 in. So our 6's are going to cancel, and then our 6 here is going to cancel with 2, we're going to get a 3. 5 times 11 is 55. So 55 times 3 is going to be, just do the math off to the side real quick. I'm going to get 15. So we're going to get 165 in the front plus 15, which is just going to be equal to 180. So that's how you go about using your sum and difference, your summation properties and then formulas. So let's do one more, and then hopefully you guys will be okay to do them on your own. So this one's a little trickier. So we have the sum from I going from 1 to n of I plus 1 over n squared. So we don't have any numbers to work with, but that's okay. So remember how at the beginning we talked about I as your indexing variable. So you only want to have your i's on the inside. Every other variable is considered a constant. So this 1 over n squared here is just a constant in this case. So we can use our constant rule for summations and pull it out front. So we're going to pull the 1 over n squared out front. And then we're going to have the sum from I going from 1 to n of I plus 1. And so now we're going to use the sum and difference property of summations to split that up into two sums. So now I want to make sure that 1 over n squared gets multiplied into both of them. So we're going to put brackets around them. So I going from 1 to n of I plus the sum of I going from 1 to n of 1. Okay, and so now we're ready to use our summation formulas. So before we use them, we better write them. So the sum from 1 going from I to n of a constant is just equal to c times n. And from 1 to n of I is just n times n plus 1 over 2. So since we already have n's at the top, we're just going to plug in for what we have right there. So put that 1 over n squared out front, draw our bracket. We're going to have n times n plus 1 all over 2 plus c in this case is 1, so we're just going to do plus n. And now all we're going to do is multiply n by 1 over n squared and simplify. So we're going to get n times n plus 1 over 2n squared plus n over n squared, which if we cancel, we have an n up top here. We can decrease the denominator's power by 1. Same thing over here. So our final answer then is going to be n plus 1 over 2n plus 1 over n, which if you wanted to write it as one fraction, we could change the top here to be a 2, put a 2 here in the bottom just by multiplying in by 2 over 2 into that second fraction. We could get that this is really n plus 3 over 2n. So either answer is fine. And so this is a great example problem because when we get into area and all of that, we won't necessarily always have a number at the top because eventually we're going to take the limit of this as n goes to infinity. And when we do that, the summation really almost becomes an integral, and we're going to see how that starts to work out as we learn about how to find the area under a curve. Okay, so thank you so much for watching. I hope this helped you out. Have a great rest of your day.